I just wanted to mention, so I'm just going to do a bit of a talk and give you a little bit more detail about what we want to do with the bee lab, and just a bit of an overview of some, observations for Varroa mite. There's a symbol in the middle there called Bees for Sustainable Livelihoods, and I just wanted to explain, this is a bit of an arm of the Bee Research and Extension Lab that we have at the uni. It's something I've been working on for about 8 years, and as Rod was mentioning, a lot of the work that we'd been prior doing was on bee biosecurity, managing Varroa mites and other types of mites like tropicalaps and things like that in other countries. And we do that so that when we get these problems, we're not spinning circles going, what do we do? We already have some answers and some capabilities to do research in the country. And those projects are funded by ACR. So I just wanted to mention that's an important part of the work that we do as well, if anyone is interested. So the bee team, so we've got Pete. Pete's our apiary technician. And he's looking after our bees for us and setting them up. So it's not a lot of fun introducing pests and disease into beehives. You end up killing a lot of bees. It's not ideal, but that's for the research side of it. But also we have Isabella, so she's down the bottom there on the left. She's not here at the moment. She's been recruited from overseas because a lot of the Varroa experts are overseas at the moment. We've got Pip down the bottom. Ravnil Prasad is at the top. So he's based in Fiji. He's doing his master's looking at oxalic acid and other existing miticides and their impacts on Varroa. And then we've got Nikhil, he's doing his master's on honeybee nutrition, supplementary feeding. And then we've got Annalise Austin, so she's just wrapping up. Annalise, is she in here? She's probably busy up the top. So Annalise is doing her PhD looking at value chains, product development and social inclusion in beekeeping. There's a coconut down the bottom, in the bottom right-hand corner. Talis Chris is another student. He's looking at cane toads and fencing around that. And we've got Shane. Shane, are you in the audience? Yeah, Shane's just there. So Shane's potentially starting his master's with us looking at sugar. It seems very simple that you think sugar is a sugar, but some of the preliminary analysis we've done is actually showing that not all sugar is made equal. I've tested some and it's really high in sodium, for example, which is toxic to insects, but it seems simple, but no one's really looked at it. So that's a bit of the bee team. It's slowly growing. We've also got some advising gurus. And these are adjuncts that we have at the university. So we've got Professor Doug Somerville, David Lloyd, who was here just earlier, Dr. Dennis Anderson, Dr. Diana Lehman. So I don't know if you guys know Doug, but he was one of my PhD supervisors. He was in the bee industry for 45 years. He's a bit of a guru, and I love chatting to him about all sorts of things because he tells me I'm an idiot endlessly, but I learn a lot in that process. Dennis Anderson. I don't know if you guys have written the scientific name of Varroa destructor in a paper before, but you have to cite that guy's name because he discovered it. He's done a lot of work on different mites and also the viruses of them. Diana Lehman, her work is in microbiology, and I'll explain why that's important in a little bit. So they're not employed, they're just volunteers, but they're advisors to us and the project. So as I was saying, we've done a whole bunch of work for a number of years looking at a whole range of different things to try to control these Varroa mites. Chemical controls, both synthetics and organics, and brood manipulation. We've been working with these industries on the registration of different products, the education, the training and the extension in those countries around how to get good information out to beekeepers. So we've been doing a whole bunch of different research in some of these other countries looking at cheaper ways to control these Varroa mites. And what these projects have taught me, and what Doug taught me and David in my PhD, was that there's no point in just me going over to this country and looking at something that I can publish, like, there's a virus of bees that no one's ever heard of, and I can publish that because it's really novel. These projects are designed at the end, you have these end of project reviews, and what happens is they contract someone that wants the project that I've had funded, and they basically sit there, they don't even ask me a question. They just ask the beekeepers. They say, was that project any good? Did you get anything out of it? And if they all sit there going, I don't know, I won't get another project. So these projects have trained me into trying to really engage with industry in a level which you guys are seeing benefit from that. So I really hope that that's something we can achieve here at SCU as well. So some of the barriers to good beekeeping R&D impact that I've learned over the last few years has been not addressing the root cause of the problem. So you could imagine, let's say hypothetically you go to P&G, you might think, oh, this Cooper guy goes over there and gives them some training because they don't know what they're doing. Not at all. that doesn't address the root cause of the problem. The root cause of the problem there is they don't have any local trainers. So if I go there, I'm not solving the problem. The problem just perpetuates. The problem is there's no local trainers there. So that happens in research quite a lot. Inadequate end user consultation and participation. That's a two-way street. I need to consult with you guys. So Roger said something about small hive beetle. That's my ears prick when I hear ideas. I'm like, cool, tell me more. What do you want to do? What do you think the solution is? But it's a two-way street. I need to listen to you, but you guys also need to participate if you think that it's interesting. And that's in the project design phase as well, not just doing the research, but actually formulating those project ideas and implementing it together. Limited collaboration. You have different research groups and different associations doing different things. We have limited resources. The more that we can tailor that into strategic outcomes so that we're thinking about what does the beekeeping industry look like in 5 years from now, not the problem of just today. Under-resourcing, monitoring and evaluation and learning and extension processes. So this is around actually going, well, we did this research, nothing happened, but then not just leaving it there. Actually saying, okay, why did it not happen? Why did it not work? What did we learn from that? Why, so that we don't go and spin that circle again somewhere else and waste money on it in another 20 years when it's just been covered in dust, because that does happen. And the difference between an output versus impact. An output is me writing a report. The impact is that you read that report, or I stand here and you learn something new, and then you go and implement it, and then your bee's looking better. That's impact versus an output. They're very different things. So there's some of the lessons that I've learned. All right, now let's get on to a little bit with Varroa. So hands up if you've actually had a look for this bug. All right, keep your hands up if you're telling the truth. Oh, okay, hands are going. So there's a lot of uncertainty right now. I've been chatting to so many beekeepers have been chatting to one another, and there's so much uncertainty in beekeeping businesses right now about what to do. What am I going to reach out for? How am I going to manage this? So it's probably like no other pest that we've ever seen come into the country. There's a whole range of things that they're doing to our bees. They're not just biting them. They're doing lots of different things. So you could imagine they are biting them, but they're in the development stage under that capped brood, and it causes physiological deformity. So you could imagine if you're a bee and you come out and you don't have an antenna, that's not great. And the same for a wing, you kind of need that if you're a bee. They have reduced life expectancy, reduced fat body tissue, and that's really important because the fat body tissue is like the liver of an insect. Insects don't have a liver. They use their fat body tissue to detoxify things from the environment so they then become more susceptible to some of those pesticides. It reduces their weight, their ability to orientate and to fly and to learn and to communicate, and also spreads, exacerbates, and activates viruses. So as beekeepers, we don't talk about viruses that much. Well, I mean, I don't hear it that much. Maybe I'm just hiding under a rock, but people are not really talking about viruses that much. Maybe you see a bit of sac brood virus every now and then, but there's studies that show in Australia that actually a lot of beehives, I think it was 67% of colonies, of 1,500 colonies that were sampled across every state in the country had black queen cell virus in it. About 30% had Lake Sinai virus and others. So, and I think it was like 30% of colonies had like more than 3 viruses, but we just don't see it, right? Because they're there at levels which are not really causing much of a problem, but Varroa's about to change that. So it's not a lot of fun. That bee there is not going to be producing much honey. So the impacts that these Varroa mites have on an individual bee is really different to what happens at a colony level. It's not necessarily the same thing. As beekeepers, we observe these mites in the colonies that they're significantly lighter, they're weaker, they're lethargic, they're depopulated. That's what we see as beekeepers. We're also going to have to keep out for parasitic mite syndrome. I never forget when I go overseas and you see these colonies, you're like, there's AFB. My eye just goes straight to it to see this uncapping that's going on. It's not AFB. We do the PCR and culturing on it. It's not AFB. It's just this pupa that's just disintegrating. It's just rotting in there. It doesn't rope out. So it makes identification of AFB harder when you've got this going on. Patchy brood, chewed out larvae, sunken cappings, etc. It exacerbates disease spread between colonies because you've got weaker colonies, and what happens to weak colonies? They're more likely to get robbed out, and therefore they'll be spreading those diseases. And there's also research that suggests you have high rates of queen supersedure and lower queen acceptance when you're re-queening as well, potentially. So that's the impacts on sort of bee colonies and on individual bees. But as we know, it's not just about honey, it's also about the broader industry and impacts on growers. So what happened in New Zealand and America is that they lost about 50 to 60% of their registered businesses, but the number of hives that they had and the amount of honey they were making actually didn't change that much. If you look at a graph, it's kind of just this, but the business numbers went like this. So this is the leading cause of colony losses, but honey production and hive numbers stay the same. That's a bit confusing. Why? Beekeepers are good at making bees. I mean, it's not, you guys are great at it. And the reality is that 8% of beekeepers in this country own about 90% of the beehives. Most commercial beekeepers own so many hives, and they're going to manage the mite and they're going to make more bees up, but it's still a lot of losses. Like I was saying, we're going to lose a lot of our feral bees. Growers are heavily dependent on feral bees, and it's largely unquantified. Ask a grower what number of honeybees on their flowers are from the ones that they're paying for versus the ones they're not. No one has the answer. There's also synergistic chemical impacts on bees. I was just having a chat to a few people earlier about this. Is when you start putting these miticides in combination in beehives, they can also increase their toxicity when they're in contact with other things that are putting in there. So, for example, Apistan, in combination with OTC, becomes more toxic to honeybees. Or if it's in contact with fungicides that are in the environment, it's more toxic to honeybees. So there's multiple synergistic impacts going on there. It's like it's not ideal. We need to look at it more and study it more. So we can anticipate more money and time to monitor and manage this mite, more time and money to make more splits and replace lost colonies. There might be business opportunities for package bees, nukes, pollination business opportunities, but ultimately we're going to have a significant increase in costs of production. So it's really critical that we know our margins and how much money we're spending to make that money come in. We need to encourage growers to be proactive about their understanding of the amount of free pollination that's currently occurring. So let's talk about economic thresholds for a second. So over 3% globally, which is 9 mites in a 300 sample with half a cup of bees, is bad news, right? But the reality is our conditions here are really unique. So our bees are naive to these mites. They've never met them before. We have brood all year round. Who's got brood all year round? Hands up. Okay. So that's pretty different to all the research that we've got that's out there from temperate climates predominantly. We've just got this haven for breeding these Varroa mites. It's going to be really difficult. And also, like I was saying before, about the amount of feral bees, as they start dying and our bees start robbing them out because they're being managed for these mites, you're going to get this massive invasion of mites coming back in. It's going to be very bloody difficult to deal with over the next few years. To summarise that, you're going to have to make contextualised decisions based on what you're observing in your beehive at that point in time. I don't believe there's just a magic number that we can just pull out of the air at the moment. We just don't have enough information. We're entering a data-free zone. And you guys are going to observe what numbers of mites reflected in the colony and their health. You have to relate those two things for your context in your business. You might read some things about monitoring. It gets pretty confusing pretty quickly. There's lots of different monitoring methods and there's lots of information already available online, so I'm not going to go over how to do an alcohol wash or a soap wash or anything like that. But I think from a research perspective, it gets really difficult for me to ascertain exactly what the findings mean because there's so many factors influencing the number of mites you get in a wash. I mean, 15% of the mites are on the adult bees at any one point in time. They're mostly in the brood, right, reproducing. But that 15% isn't static. It's a continuum. It's changing all the time. So this is just a couple. I brainstormed this for about half a second. Some of the factors, if you were doing this monitoring, that would influence the results. The size of the colony, any stresses they're under, the brood phase, the genetics and susceptibility, any immigration and any migration. So mites are coming in, mites going out, drift between them, the reproductive rate of those mites, the method that you select, whether it's a soap wash or an alcohol wash, the concentration of that alcohol or that soap or the type of the soap that you select, which frame you pick out of a beehive, how long you shake it for, like the list goes on. All of those things individually could really change the numbers up. And so what we're trying to do is understand the number of mites in there so you can make an informed decision. But the numbers are pretty bloody confusing. And there's not really an answer at the moment. The reality is it's just a conundrum that these methods are very useful and people are doing them around the world for a reason. But to increase the reliability of that information that you're getting from doing that monitoring, I've got these 3 sort of things that you can do. So really you need to re-wash the samples. If you get 300 bees and you wash it for 20 seconds, for example, you're going to get about 70 to 80% recovery. So you may be 30% out. If you re-wash it, you're going to increase that. If you re-wash that sample. If you test more colonies, you're going to get a better picture of what's going on. If you test more regularly, you're going to get a better idea of what's going on. All right, how fun does that sound? That sounds like a heck of a lot of time and energy and money for a lot of businesses. For some people, they're going to go and do this, you know. Like we're going to do this on our research paper. It's going to be monitoring the hell out of them to try and understand exactly how many mites are in there as close as we can. But I understand that for businesses, that causes a conundrum. So I want to read this slowly. Proficiency in estimating mite loads is a critical beekeeping skill, not only for avoiding unnecessary treatments, which cost money, but to verify damaging levels, determine the efficacy of treatments, and identify resistance. I think it's pretty important. So we need to use a consistent and reliable monitoring method. If you one day do a sugar shake and then the next day you do an alcohol wash with a different type of thing and you shake them for a different point in time and you're not comparing apples with apples, do something consistent, I would imagine, is the best way to get a consistent picture to compare. The same level of mites poses totally different risks in different seasons. Ideally, you want to check the mite levels before and after treating, but this is very idealistic for a lot of people. Mite load comparisons are probably going to be really confusing. A colony that's got heaps of viruses in it might tolerate less mites. You might trying to compare these numbers with other beekeepers. It's going to be confusing. I think keeping records is going to help us to understand what we're doing and learn from that. So what's in your Varroa toolbox? If I was to ask you, what are you going to do? Hands up who's already got mites in their hives? Yeah. All right, everyone's all excited for them to turn up. So I think that we really need to be thinking about all the different things that we have in the toolbox because there are so many things. In the literature, I've found more than 130 different things that can kill Varroa, right? There's peer-reviewed science out. Not all of them are commercially available. It takes a long time to go from the science to having a commercially available product. Some of them might work for Varroa, but they also harm the bees. So there's lots of different things. This is not exhaustive. As you go up this pyramid, the efficacy increases. That means, you know, the amount of mites you're killing is greater. The reliability of it increases when you use more of this. The higher you go up this pyramid, they're more reliable methods. So if I put Baverol in, I know that's going to be highly efficacious, and I know that it's going to be reliable. I'm going to get 95% knockdown each time. I could be pretty sure of that until we've got resistance issues. But the risk also increases as you go higher up in terms of the residues that we have in our products and the impacts that they can have on bees and bee health. Also, the risk goes up in terms of resistance issues and the cost goes up. So you can see there's a conundrum there. You're getting better mite control that's more reliable, but it costs more and you've got more residues, more resistance and money. So it's just a bit of a conundrum. But I guess part of the answer is trying to understand all of the tools that we have in the toolbox. And at the moment, I'm not hearing lots of different things coming in. And we really need to, and I would love to do some more things here at the uni and engaging with associations and everyone that's already out there doing lots of really cool things to try to get some of these methods really clearly communicated. Not just talk about them, do them, and design your own IPM for your operation that suits you. So this is a whole list of some things that's not in your toolbox I'd like to check out. There's scientific evidence that these things can kill mites. I don't recommend going and putting them in your beehives. Like I said, that's not extensive. There's 120 of these or more we've identified. There's so many of them out there. There's all peer-reviewed papers on that. But some of those, if you go and do this, you'll hurt your bees. So we haven't dialed that out, but there's lots of really cool things to go and check out there. So chemical controls can keep Varroa populations low and colonies alive, right? Which is what we all want. But it also selects for stronger mites and wimpier bees. Another conundrum we don't have the answers for. We need more people doing more research on this. It's a bit of a trade-off because when more of your income comes from bees, you can't afford to lose more bees. If I've got 3 beehives and I don't really generate much of my income from that and they die, I can afford to not necessarily treat with synthetic chemicals, for example. So it just depends on what's going on. And I think part of what people are doing is based on the amount of income that they generate from beekeeping. It will dictate the response that they'll tell you. So anyway, that's just another conundrum. So part of the solution to that is breeding Varroa tolerant or resistant bees. However, you can talk to lots of different researchers and industry around the world, and there's actually been very low adoption of some of these Varroa sensitive hygiene, which has many different traits within it, adoption within commercial beekeeping businesses. And I think that's very interesting. There's obviously a complexity or a trade-off with the cost of evaluating different traits. It takes time to evaluate a trait, and bee breeding takes a lot of time, and therefore those breeders need to be remunerated for their time. But if you've got a really expensive queen, you also need to, when you're purchasing that, work out whether it's worth your money or not. And this is for bee breeders, the producers of bulk queens, and then the beekeepers that buy those bulk queens. So there's huge challenges around that. I think there's a lot to be said that not in sophisticated bee breeding programs, but even simple things that we can all do to contribute, like, you know, propagating those colonies that look good, that have, on average, lower mite numbers, and getting rid of those genetics which have above average higher numbers. You have to look at your mite populations anyway, and if you're already doing monitoring, that could really help in terms of where you go to make your splits or where you're grafting from. So low mite populations and low mite population growth selects for any trait that keeps the mite populations low. It's pretty quick and it's cheap. So we can also do harbo assays and things like that, but it becomes more expensive. And lots of bee breeders, they have their own breeding objectives, right? It's pretty difficult to get 2 businesses to come together and say, you should do it this way, or you should do it that way. I don't believe it's possible. I think that you just need to support private sector individually in each business about what their objectives are to achieve that. We don't have to reach the moon, we just have to reach the community. And the best strategy, obviously, is your own. If you ask 10 beekeepers about what their strategy is, you get infinite answers, exactly infinity, that number. So you need to just absorb all the information. There's no solution like that person knows all the answers. That isn't out there. You just have to try to absorb in the information. If you can understand 15 different things that you could have in your toolbox and why you're going to select which tool at which time to achieve what outcome, you'll be really successful. And you need to obviously use those tools and then observe what happens and then get that feedback based on the results that you're seeing. So we've got these beehives and we're going to be doing a bunch of research and ideally not just doing extension ourselves, but collaborating with people who are already doing extension. We're trying to double up here. So we want to do things that are really practical based on the research that's out there and peer-to-peer. So who thinks that beekeepers are going to really listen to me so much as they would listen to someone who makes most of their money from bees? Me or the person that makes the money out of bees? Hands up if you think me. I agree with you. Oh, well, thank you. I wasn't expecting that. Beekeepers are going to listen to beekeepers, right? It's not rocket science. There is science out there about who people trust and what information that they're providing. Ultimately, imagine if I get all the commercial beekeepers in Australia who are organic certified to come here to do a workshop and they share knowledge and skills of what they're learning about their operations on what's working for them in terms of managing mites. I guarantee you they're going to learn something from one another. You can do this on lots of different levels. Imagine if you got all the bee biosecurity officers from every state in the country to come together to give peer-to-peer feedback on practical theoretical topics and say, hey, what's working in extension? What if you got all the bee researchers together? The same thing. So this concept of peer-to-peer learning is really powerful, and I've seen this happen in a number of different places. We're going to do some things with what we're doing here, but we're not going to set up a bee breeding program where, you just come here and we're going to supply them. It's not going to work like that. It has to be driven by private sector. We have students, we have labs, we can do harbo assays, we know about biology and ecology of these mites, as do you guys. And often, a lot of the breeding programs that you see overseas are actually a lot of volunteers that are connected with private sector that are driving that. They don't have these huge multi-million dollar budgets. Some of them do. But some of them are really successful. They're just drawing on the collective talents of people that are trying to improve the quality of their bees. And we would love to be a part of that. And I've had a number of queen breeders reach out already about a number of different ideas, and we just got to try to gather that momentum and that energy and see where we can go with it. We can apply for grants. They don't have to go through the uni. They can go through other organisations too. I'm really interested in doing more research about affordable and effective Varroa controls. The root cause of the problem for overdosing with lots of synthetic chemicals, what's the root cause of the problem and of that? Is it or the resistance issues, for example? Is that because beekeepers are over-treating? Or because they're using something that's really cheap? Or because they're not rotating? Yes, these all cause resistance, but the reason why beekeepers are probably reaching out for that and doing that all the time is because it's so damn expensive. The narrative changes pretty quickly if I said all those things only cost 30 cents. You go, oh, okay, I'll just use that one and then that one. That's a little bit easier. You can start doing that a little easier. So the root cause of that problem is that it's expensive, and so we need more affordable solutions for Varroa, and that's not easy. But it's actually happening in lots of other countries. The beekeepers are very innovative and very creative. So we're really keen to look at a number of those different things. I'm keen to do some more research around monitoring and thresholds. What is the economic threshold in Australia at a certain point for your bees right now? If you've got, let's say you're getting 9 mites, what do your bees look like? And it's going to be a moving feast as we have more Varroa, as we have more feral colonies collapsing, as we have more viruses that are spreading through the environment. So it's a changing landscape. Ethnopathogenic fungi, that's a bit of a word. So we've got 2 different species of fungi. We don't have any biological controls. If you look at that IPM, we don't have any that are available. But if you look at other sectors, they've got heaps of biological controls. Metarhizium and Bovaria are 2 species of fungi that have shown to be really promising at killing these mites. So we're going to be looking at some of those. Diagnostics and residue testing. So a number of people have said to me, what services are you going to provide? Are you going to test honey for MGO and do this and that? My answer to that is that we're going to do what is not already out there. Peter Brooks, the University of the Sunshine Coast, they've already doing some really cool honey chemistry and that sort of. I'm going to send people there. That's great. If there's already a lab that's doing some diagnostics for AFB and qPCR and culturing, send them there. But maybe there are some gaps, and I think perhaps that we don't have many labs in the country at the moment that are going to be doing residue testing. We actually send a lot of our samples overseas. So in terms of that, we'll do what people finding it's interesting, but also probably what's not already out there. And biosecurity, I think, is a really interesting one as well in terms of some of the research that we have overseas and how that can also impact us, is that just because Varroa is here now, that's not the end of the line. There are so many pests and diseases that we do not have here, and we don't want them here. And if they come here, we need to understand them now so that if they come, we're not just scrambling and chasing our tails. So not many people have seen footage of this, but that's Tropolaelaps mercedisae in Papua New Guinea. How good do those bees look? Breeds twice as fast. Their phorotic stage for Varroa is about 2 weeks. That has 12 hours when it's not breeding. They will overtake Varroa. That's how fast they breed. We don't have any data on this because it only affects poor people in the highlands of PNG. Every virus that can be transmitted by Varroa has demonstrated, not that they've all been tested yet, but can be transmitted by this as well. So it's arguably just as big, or if not bigger threat potentially. I was saying before about collaborations, so not just with industry here and other researchers and bee associations and private sector, but we need to be drawing on the collective talents and knowledge and skills of all these other bee research labs. Look at them all. You don't need to read that. You'll have to get yourself into Specsavers to be able to read that. Sorry, the text's so small, but there's like 20 different bee labs up there. Well, I'm not going to sit here and pretend that I know everything about Varroa research. I love it. I find it incredibly interesting. There's people that have dedicated their lives for 40 years I'm not going to ignore. And I want to invite them to come here, to do presentations, to do seminars, to learn from them, to be mentored by them. to have other people in the industry that can connect with them. So one of those researchers, this is a pretty young guy, he's had some really good mentoring, is Cameron Jack. So he's going to be coming to SCU on sabbatical. He'll be here for at least a year, maybe 2 years. He'll be based here. That's not for another year or two. He's got that in play. So I just wanted to mention there's some other labs out there doing some really amazing things, and we need to try to draw on their knowledge and skills and the things they've already learned, not reinvent the wheel. We want to have some school engagement programs. Pete's going to be leading part of that. So how do we get the next generation of beekeepers into the sector? Engage people at high schools, get young people in, and maybe they could even nominate some of the key people that they think are, really bitten by the bee bug. Obviously they sting, but there's people that just get hyper addicted to it. Send them here. We can do like really intensive workshops with them, get them exposed to research, go and work with some commercial beekeepers so they get exposure to the industry. Running field days, so we can run some, but we'd also like, if you've got some field days that you're running, there's no reason why that you can't run them here. These bees don't necessarily belong to me. They belong to, there's a regional public good. They belong to anyone can come and use this as a resource. Like I was saying, we'll have some seminars that we might host here on different topics, and we'd love to reach out to you guys and hear what you guys would like to see, and we might host some events, etc. We've got some student scholarships that are available. So this is across a whole range of things. We've got 2 different PhDs that are advertised at the moment. And we've got a number of honours and master's students that are starting as well. But if you know of someone who's young and enthusiastic about bees and they want to do bee research, we'd love to hear from them. They're not just supervised at SCU. We also look for national and international collaboration in terms of the supervision of those students. If you have a research topic that you would like us to investigate, we want to hear about it. It needs to come from private sector. Beekeepers need to tell us what we should be doing. We're here, we want to do things that add value to your business. That's pretty much the main thing there. So the SCU Bee Club, as I mentioned, so this is open to the general public. If anyone's interested, feel free to. Oh, Steve's going to join. Oh, right.
I've got the list going around, Coops.
Awesome. Yeah, so the Bee Club's there, undergraduate students, postgraduate students, and yeah, we'd love anyone to get involved in that. And the idea there is that we've got undergraduate students that are going through, and they're not just getting training in whatever the course it is, they're also getting exposed to beekeeping at a practical level. We've got a website up. It's pretty embarrassing. There's a picture of me and Pete on it. We're going to change that. We're going to create some really long videos that go for hours. No, I'm just joking. That sounds boring. We're going to want to do some things that are just really short, sharp, and to the point, that are peer-reviewed based on the science. I want to review science and get that out to beekeepers. Not just the science that we're doing, but the science that's just out there that can be helpful for businesses. We don't want to do what's already out there at the moment. We're going to have a newsletter, and that's not just going to communicate what we're doing. If you've got an event, I'd love to share that. If there's a paper that comes out of a lab, I'd share that. But if one comes out of Peter's lab, I'd like to share that too, because I think it's great for beekeepers. If a lab overseas in America publishes something that I think that's really interesting for beekeepers, I'll just find what's one sentence in there that's relevant for beekeepers and just communicate that. Try to get the information out there a little bit more. I'd love to do a podcast, but that's probably a little bit in the track. So I want to be able to communicate practical beekeeping research and resources as a bit of a hub online. All right, bear with me, almost done. So in terms of funding, this is the real reason why we brought you guys in here. The reality is this is not for profit. We're not trying to make money out of this. Any money that we have in our budgets goes into supporting and paying for local people's salaries to do bee research and extension. That's the reality of it. So we've got time at the moment to keep Pete and Isabella on, the postdocs, but we really need more students to be signing up to do postgraduate research. They're going to be a huge component of the bee lab, is the students that are out there solving problems that you guys are communicating to the lab. And also from a lot of volunteers. If you look at other labs overseas, they actually have a lot of volunteers that actually connect and mentor students that are in there that are doing research or are part of the bee club, etc. Obviously, you're going to be applying for R&D grants. That's how researchers get you their bread and butter. But as I was saying, the beekeeping industry doesn't really have that much funding. So that makes it pretty tricky at times. We're doing some fundraising. Well, obviously, we've got bees, so there's going to be nukes that we're going to sell. And we're also, we're going to be looking for sponsorship. Should I spend the small amount of money that I've got left from the budget on buying some new bee boxes, or should I have a sign here saying this is a beekeeping company and they're doing cool things and we've tested stuff on it? So we're looking for sponsorship. See these pictures there from University of Guelph at the top and University of Florida. The majority of the funding from those bee labs was generated from beekeepers because they believed in those labs. That's inspiring to me. I don't see that currently in Australia, that sort of industry-driven approach to seeing benefits that are tangible coming out of universities like that. All right, so I'm going to wrap it up there, guys. Anyone, if you want to be in touch, you find this up there, but you can sign up to our mailing list and we'll send you out any information about things that we're doing from that point in time. And yeah, and go from there.